So it says a circular cylindrical metal container open at the top is to have a capacity of 24 pi inches cubed. Now, since it says cubed, you know it's a volume, right? So we're talking about volume there. That's the volume. So the cost of the material used for the bottom of the container is 15 cents per square inch. That's an area, because you can see it's squared. Okay, so we've got the area of the bottom. The area of the bottom, I'll call that A sub B, or you could think of that as the surface area of the bottom, is going to, which is going to be pi r squared for whatever r is, and that costs 15 cents. Let me do that again. 15 cents per cubic inch. And then it says the cost for the material used for the side of the container is 5 cents. So this would be 5 cents. The cost for the surface area basically of that cylinder, right? Because you're going to have this cylindrical thing like this, and if you cut it open and you spread it out, there's a rectangle. If you cut this thing right here and you spread it, there's a rectangle, and that top piece right there, that's that right there, which is 2 pi r, and this height, which is going to be here, that height is h, which is right here. So 2 pi r times h is your surface area of your cylinder. So 2 pi r h, and that costs 5 cents. Okay. So it says find the dimensions that will minimize the cost of the can. All right, so this is a calculus problem. Minimize the cost of the can. So this is a maximization or minimization, optimization, covers both of those problems. So what we're going to have to do is we're going to have to find. So we're going to have to come up with the cost function. So my cost, it says find the dimensions that will minimize the cost of the can. So let's come up with the cost. The cost of the can is going to be equal to 15 cents times whatever the area of your base is, which is that. I'll fill in the variables later. Plus 5 cents times whatever the cost of the surface area of the side is, which is 2 pi r h. So you see what I'm creating here is this is the area of the base, the circular base, and that's how much it costs me per square inch, right? This is the area of the side, the lateral area, lateral surface area, and that's how much it costs me. So that when I add them together, I'm going to get the total cost. Now, I have a lot of variables in here. I've got R, actually I just have two. I have R and H. So now what I'm going to do, and this is how you do it for most of these kind of problems, most of these optimization problems, is you come up with an equation that you need to maximize. So this equation is what I'm going to I'm trying to maximize or minimize that, which we'll talk about in a second. But I'm going to have to eliminate one of these two variables in order to do that. So we have to get rid of either R or H, and the way we're going to do that is by this volume equation up here. We're going to use the capacity. It says the capacity is 24 pi inches cubed. So we're going to use that to come up with a way that we can relate R and H. So we know that the volume of a cylinder, you see that equation up there in red in the upper right hand corner, is equal to pi r squared h. And we know the volume to be 24 pi. So that's how we can relate h and r squared. So we're gonna choose whichever one seems maybe a little bit easier. We're gonna solve this in terms of either h or r. And let's just go ahead and do it in terms of, let's do it in terms of h. Okay, so I'm going to cancel out the pi's, and I'm going to divide, so h equals 24 divided by r squared. Got it? So we're going to take that and plug it back in everywhere we see h, which is just one place. And then we're going to use that equation, simplify it as much as we can, and that's the equation we're going to take the derivative of. So if you remember your basic thing from calculus, the way you find the max and min point on a graph, you take the derivative and set it equal to 0. It's like one of the biggest takeaways from Calculus 1. So let's do this. I'm going to make some room for myself over here. First of all, we're going to solve this equation. I'm sorry, not the volume. Not that equation. We're going to take this equation, C, and we're going to write it in terms of R. So notice I'm calling it C of R because I'm going to only have one variable, just R. And I'm going to write that as 0.15 pi r squared plus that times 2. What's 0.05 times 2? It's 0.1. 0.1 pi, and then it's going to be times 24. Whoops, I guess I should have cleaned that up a little bit. Times 24 over r squared. Sorry, there's an r here also. Got it?
Yeah.
So that equals, again, let's clean it up, 0.15 pi r squared. 24 times 0.1 is 2.4. 2.4 pi, and one of those r's is going to cancel, so you have an r on the bottom, because one of those r's and the r squared on the bottom canceled with the r that was up there in the top. Got it?
Yeah.
So that's my C with respect to r, or in terms of r. There's my equation. Now, does your teacher let you use your calculator to find the derivative, or do you have to do it manually?
No, but I know how to do that manually. You would just bring it up. You would bring the r up, and then it would be to the -1, right?
Right. So C prime of r equals, you bring this 2, bring that 2 down front and multiply it. So that's what, 0.3?
Yeah.
0.3 pi r plus, actually it's going to be minus, because right, this is an r to the -1. So that goes in front, minus 2.4 pi r to the -2. Check for errors. Make sure you don't make silly little mistakes, because those will crush your answer. And now I want to set this. Remember what we talked about. This is just some sort of a graph. We want to set it equal to 0 and solve it. Because you remember basic calculus, if I have like some graph here, that point and that point can be found if I take the derivative of that function and set it equal to 0. That's how I find the max or min points. So this is just some sort of graph if I graphed it. It's actually going to be a rational function. It's some sort of rational function if I graph it. But I want to find out when that equals 0. So set this equal to 0. For the sake of space, I'm just going to erase that and put a 0 here. Okay? So let's just move this over to the left, because it's negative, so it'll be positive. 2.4 pi r to the -2 equals 0.3 pi r. And remember, r to the -2, that means that this is really on the bottom. I do that because now I can just multiply it to the other side, right? So I'm going to do that, cancel it there. So that's r cubed on the other side. Now let's divide both sides by 0.3 pi. So the pi's will cancel out, and you get 2.4 divided by 0.3, which is what, 8?
Yeah.
Oh, that's nice, because what's the cube root of 8? Exactly. So R equals 2.
Okay.
Now, if R equals 2, it's really nice when you get good numbers like that because you know you probably did it right. All I have to do is plug it into here to find out what H is because they want the dimensions. Always ask what are they asking for. They want both dimensions. So R squared, 2 squared, which is 4. 24 divided by 4 is 6. So H equals 6. So your dimensions are radius 2 inches, height 6 inches. And those are your answers.